Hi everyone! In today's lesson, we are going to go over chemistry nomenclature. In today's lesson, we are going to learn how to name covalent and ionic compounds. Some skills you will acquire by watching today's lesson is you will understand the basics of chemical reactions, you will learn about ionic and covalent bonds, and you will learn how to name ionic and covalent compounds. Before we begin naming chemical compounds, we should understand what compounds are. Compounds are made when elements combine, and all of the elements that exist today are presented in the periodic table. A picture of the periodic table is shown. To read the periodic table, we need to know what groups and periods are. Groups are the columns on the periodic table, and they tell us the charge of elements. Periods are the rows on the periodic table, and they tell us the amount of valence electrons in the outermost shell of each element. As a note, keep in mind that in this lesson, we will only be using the group number. We will not be talking about the periods. So how can we tell the charge of a particular element or atom by knowing its group number? Well, essentially, every single element that belongs to a particular group has the same charge. So in group 1, all atoms have a charge of +1. In group 2, all elements have a charge of +2. In group 13, all atoms have a charge of +3. We're not going to be considering group 14 because those are a little more complicated than how the other groups work, and we're going to be going more in depth with them later in today's lesson. In group 15, all elements have a charge of -3. In group 16, all elements have a charge of -2. And in group 17, all elements have a charge of -1. Group 18 is considered the halogens or the noble gases. The elements in this group are essentially perfect, meaning that they have a charge of 0 and do not react with other elements typically.
Periodic trends. It's important to know periodic trends because they help us read and understand the periodic table. One of the main periodic trends is telling where metals and nonmetals are on the table. Nonmetals are typically on the right side and are negatively charged. Metals are typically on the left side and are positively charged. We can look at this via our group number as well. Anions, which are typically nonmetals, are negatively charged, and they can also be negatively charged polyatomic ions. Cations are typically metals and are positively charged. They can also be positively charged polyatomic ions. We will speak more about polyatomic ions later in this slideshow. What are ionic compounds? What are ionic bonds? Ionic bonds are a bond between a metal or a nonmetal. And ionic compounds are the compound composed of a metal and a nonmetal as well. So, how do I name these ionic compounds? Well, the metal comes first, and its name is unchanged from the periodic table. However, the nonmetal will come second and will always end with "ide." For example, Cl or chloride, and the compound magnesium sulfide or MgS. Let's practice. Writing formulas of ionic compounds. We can do this using the drop and swap method. This helps us swap the charges of elements into subscripts. How do we do this? Well, first, we write the symbols of the elements and their charges. Next, swap the ionic charges so they become the subscript of the next element. Then, if needed, we simplify and reduce the subscripts to the smallest ratio. Let's practice. What are polyatomic ions? Polyatomic ions are multiple atoms that act as a single particle. So, how do I name compounds with polyatomic ions? First, I will write the name of the positively charged ion. This can be a cation or a metal. Then, I will write the name of the negatively charged ion. This can be an anion or a nonmetal. Here are some polyatomic ions. You can memorize them or you may refer back to this chart. How do we write formulas involving polyatomic ions? We will again use the drop and swap method. We swap the charges of the elements to become the subscripts of the next elements. First, we will write the symbols of the elements and their charges. Next, we swap the ionic charges so they become the subscript of the next element. Then, if needed, we will simplify or reduce the subscripts to the smallest ratio. Let's practice. There are some elements with multiple ionic charges. These are often transition metals. First, we must know the following charges. Silver has a charge of +1, zinc has a charge of +2, and cadmium also has a charge of +2. Now, let's take a look at this chart. Here we have the following metals: copper, iron, lead, manganese, and tin. Here are the chemical symbols of these respective elements as well: Cu, Fe, Pb, Mn, and Sn. Here are the chemical symbols of these ions. Wait, but I see more than one. Sometimes transition metals can have more than one charge. We may refer back to this chart to see these charges as well. Copper has a charge of +1, or it can have a charge of +2. Iron can have a charge of +2, or it can have a charge of +3. Lead can have a charge of +2, or it can have a charge of +4. Manganese can have a charge of +2, or it can have a charge of +4 as well. And lastly, tin can have a charge of +2, or it can have a charge of +4. We can write the names of these elements and indicate the charge using Roman numerals. For example, if I were to write copper with a charge of +1, I would write Cu and in parentheses the Roman numeral for 1. How do we name elements with multiple ionic charges? Well, we used Roman numerals. The metal will come first and we will put the charge or the numeral in parentheses. Then the anion will come second, and if it is a regular nonmetal element, then it will end with "ide." Let's take a look at the examples. Tin 2 sulfate will be written as TIN in parentheses, 2 Roman numerals, then sulfate. However, FeCl2 will be written as iron, Roman numeral 2, chloride. Let's practice.
We learned about ionic compounds, but there is also another kind of compound, covalent compounds. Covalent compounds are formed when atoms connect through covalent bonds. And a covalent bond is a bond between two nonmetals. To name covalent compounds, we first have to change the ending of the second element to "ide", just like how we do with ionic compounds. The difference between naming covalent and ionic compounds is that with covalent compounds, we then have to use prefixes to show the number of each element. The chart being depicted in this slide shows us what prefix we use for each number of atoms. For instance, if we have 3 carbon atoms, we would say tricarbon. If we had 9 carbon atoms, we would say nonacarbon. As a note, we do not use the prefix mono for the first element if the first element in a covalent compound only has 1 atom. We can look at this example to see how to name covalent compounds. In the compound S2Cl2, we would name it disulfur dichloride. Since there are 2 sulfur atoms, we add the prefix di, and since there are 2 chloride atoms, we add the prefix di. We also put the ide ending on the second element. Please note that with this covalent compound, we do not reduce the formula even though a ratio could be applicable. What this means is that S2Cl2 doesn't become SCl, it just stays as S2Cl2. Now let's do some practice with naming covalent compounds. The first compound we have is Ni3. The first element is nitrogen, and there is 1 atom of nitrogen in the compound, meaning under the rules, mono would be the correct prefix. But remember how we talked about earlier that mono prefix does not apply to the first element, meaning the first word would just be nitrogen. For the second element, we add the ide ending and we put the tri prefix since there are 3 atoms of iodine. This gives us the compound nitrogen triiodide. For the second compound, there are 2 atoms of phosphorus, so it would be diphosphorus, and there are 5 atoms of oxygen, so it would be pentoxide once again with that ide ending. We do the same thing for the other 2 compounds and we get carbon monoxide and dinitrogen trioxide, making sure to still add that ide ending to the second element and adding the appropriate prefixes. In today's lesson, we've talked a lot about chemical compounds, but how do these compounds actually form? They form through chemical reactions. And chemical reactions are the process by which the atoms of one or more substances are rearranged to form different substances. So what are some indicators that a chemical reaction has happened? Well, a temperature change could occur, a color change could occur. Also, the presence of an odor or gas bubbles can indicate that a chemical reaction has happened, as well as the formation of a solid, which is called a precipitate. For more practice with naming chemical compounds, you can use the worksheets and games that we have linked with this presentation, as well as the videos for more guidance. This lesson was made by Hasida Naluri and Samara Nanda. Thank you for listening.